So this is 7.5 part 2. This is when the examples get a little bit more difficult, a little bit more complicated, and have a few more steps. Like for example, this one right here, we know that we have some factoring to do. And the lowest common denominator might be a little bit tricky. Another thing that these two examples are going to give us, they're going to give us solutions that directly conflict with their non-permissible values. We haven't really had, I've said that we've had to consider it, but we haven't seen an example yet where the solution and the non-permissible values conflict. So we'll look forward to that in the next two videos. Woohoo! Alright, so step one in this question, we want to factor where needed. Now, this right here, factored, don't need to do anything. This right here, factored, don't need to do anything. This one, factored, don't need to do anything. This is where it gets a little complicated. We know that this is a trinomial that can be factored. What I want to do is I want to line up my equal signs. I don't want to stick an equal sign here. That makes no mathematical sense. We want to line up our equal signs because this is an equation. So we have negative 10, two numbers that add up to negative 12x and multiply out to positive 35, x minus 5, x minus 7 equals x over x minus 5. The next thing that we want to figure out here is the lowest common denominator. This one, kind of easy to see. We have an x minus 5 times x minus 7, or just an x minus 5. So our lowest common denominator is actually going to be x minus 5 times x minus 7. Good time to do the non-permissibles. X cannot equal 5 or 7. Alright, so now what we want to do is we want to multiply both sides by that lowest common denominator. I'm going to do this in a different color. Lowest common denominator. So we're multiplying this side by x minus 5 times x minus 7. Remember guys, that's just over 1. So we're multiplying numerator to numerator, denominator to denominator. X minus 5, x minus 7, all over 1. Now the cancellation can occur. Negative 5, x minus 5 and x minus 5. X minus 7 and x minus 7. So literally folks, on this side, we have negative 10 over 1, which is just negative 10. So this side is negative 10 equals, what can I cancel on this side? X minus 5 and x minus 5. Can I cancel the x minus 7? Nope. So what's left on this side is x times x minus 7. I want to expand that. I do have to recopy this negative 10. Please notice that my equal signs are all lined up. X squared minus 7x. Add 10 to both sides. 0 equals x squared minus 7x plus 10. Two numbers that add up to, multiply out to 10, but add up to negative 7. Our two numbers, since it's a quadratic, we want to isolate the quadratic itself and then factor to see where the solutions are. X minus 5, x minus 5 and x minus 2. So we can say from here, this is the solution. X has to equal 5 or 2. Hold the phone. Let's compare. 5, 2, 5, 7. That means that 5 cannot be a solution because we said that that's a non-permissible value. Let's think it through. If x equals 5, that brings this denominator to what? That's right, 0, which means that it's undefined. So x, even though we solve for it in this scenario, once we've canceled everything out, x cannot equal 5, but it can equal 2 because that does not conflict with our non-permissible values here.